So now let's think about a situation where you know that there exists a green thing, or you know that there exists x such that phi is true. Then how do you make use of a statement like that? And the rule to do it is called existential instantiation. And this is the fourth and last one of our basic quantifier rules, and I have saved the trickiest one for last. So why is this tricky? I want you to think back to when we were talking about proof by cases. So think about when we knew, suppose you know that phi or psi holds. Then you can, and what can you do? How do we describe how to make use of an or? So proof by cases came up, and it didn't tell us that we can deduce anything. It didn't say, oh, you can deduce this, exactly this. It was more complicated than that, right? So it didn't say you can deduce phi, because you can't, right? That doesn't make any sense with how we think about how or should work. If you know phi or psi, then you don't necessarily know that phi, and you don't necessarily know that psi. You just know that at least one of them is true. So there's nothing like this. There's no one thing you can deduce from phi or psi in the basic rule for how you can use an or. So what was it instead? How do you use an or? It was proof by cases. And it worked like this. It said, I guess it was phrased something like this. Then if you can prove omega from phi, and you can prove omega from psi. So if you do a case 1, suppose phi, and then you manage to prove omega, and then you do a case 2, suppose psi, and you manage to prove omega, then overall, then you can deduce omega. So it was more complicated. It wasn't just you can deduce something from phi or psi, but it was that knowing phi or psi provided you with a strategy, proof by cases, in order to prove other things. So it's going to be the same deal here. For existentially quantified statement, if you know that there exists a green thing, then there's not any particular thing you can deduce from that in our basic rule. It's not that you can deduce that this thing here is green. Like, I can't, right? I know that something is green. That doesn't mean I know this is that something. So instead, it's not going to say, oh, here's what you can deduce. Instead, it's going to say, here's a proof strategy that you can now apply to prove other things, to prove some other fact, like omega. So let us describe that proof strategy. So then, what it allows you is, you may freely assume phi in your argument for the sake of proving something else, like omega, whatever it is you're trying to prove. And there's a caveat, a really important one. It's as long as, and the caveat is not going to make sense, is not going to make immediate sense if I leave this as a proposition placeholder phi. It's a little unclear what's going on. So let me replace it by x is green, just to serve as sort of a silly, or a placeholder example. X is green. So if you know that something is green, holds, if you know that that statement holds, then you may freely assume x is green in your argument for the sake of proving some other statement, omega. I think this is something This word something is a little bit confusing. For the sake of proving omega. As long as the variable x was not previously used for anything. So as long as x sort of is arbitrary, this is that word arbitrary again, but let me just say was not previously used for anything. And if x was in use, so I'm sort of running out of space and I want to fit this all onto the one board. Okay, obvious solution is to write a little smaller or zoom out here. So here's the rest of the rule. If x was previously in use in your proof, then you should introduce y as green. Or if y was previously in use also, then you should introduce a or b or c, or just use some variable that was not previously used. Use a new variable. So that's existential instantiation. Similar kind of to proof by cases. Instead of just letting you deduce something, it's giving you a way to prove some other thing, omega. And that way is to basically assign a name to that thing that you know exists. So this is the way I think about it, is if me and the reader of the proof both agree that there exists a green thing, we both agree that something is green, and we don't necessarily know what that something is, but we agree that something is green. And I want to convince the reader that omega is true, whatever the statement omega is. Then I can tell the reader, look, we both know something is green, right? So let's just give it a name, x. That's this step where we assume x is green. Let's just give that something a name, x. Let x be that green thing. Then we can work with that sort of hypothetical green thing named x, and if I can convince you of omega, that omega is true using x's greenness, then at the end you should be convinced that omega is true just from the fact that something is green. So here's how I would write it in an actual proof. So what I was showing you back here was sort of the general rule, a description of the rule. But here's how it would show up in your writing. Suppose we both agree that something is green, then I would write, since we know that there exists x such that x is green, comma, we may get, or we can get, an x such that x is green. Or sometimes people write, we can let x be green, something like that. And again, it's important that x was not previously used. So if I look at the writing above here, then it's important that x was not previously used for something else. If it was, use a different variable. If I don't feel like using a different variable, then let it be understood that this x is a new one. It's a new variable, not to be confused with the previous mentions of x. And the keyword here, so I'm going to use this keyword typically to signal that I'm doing an existential instantiation. Then you can fill in the rest of your proof. You know, whatever, blah, 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 prove omega. And if you can prove omega with this arbitrary name x for a green thing, then you have proven omega just from the knowledge that there exists a green thing.